Welcome to our lesson on tangents and normals to circles. So, the tangent to a circle at a point is the straight line that just touches the circle at that point. The normal to a circle at a point is the straight line that is perpendicular to the tangent at that point. So as we can see in our diagram here, this line CP is a normal to the circle, and it is also a radius of the circle. The line QPR is a tangent to the circle. A couple things to note. 1. The tangent to a circle is perpendicular to the radius of the circle, and 2. The product of the gradients of perpendicular lines is equal to -1. Or in other words, M1 times M2 is equal to -1. Let's get into an example now. Let's say we're to find the equation of 1, the normal, and 2, the tangent to the circle, x squared plus y squared plus 2x minus y minus 5 equals 0 at the point 1, 2. So, how do we go about doing this? Well, first off, for the normal, to find the center, all we need to do is simply divide the x and y coefficients by -2. So 2 divided by -2 gives you -1, and -1 divided by -2 gives you a positive 1/2. So the center of the circle is -1, 1/2. Next, it would be good if you were to draw a sketch. So here, this is what our graph looks like. We have our circle with the center -1, 1/2, and relative to that, the point 1, 2 is to the right and above it. Next, we find the gradient. Before we go any further with finding our gradient, according to our sketch, the gradient of the radius, which is also the normal, is going to be a positive number. It is sloping upwards. It is going up as it goes over to the right. So when we get our answer, we should expect to get a positive number. So when we find our gradient using the gradient formula, y2 minus y1 over x2 minus x1, we substitute our values. 2 take away 1/2 over 1 take away -1. 2 take away 1/2 is 1.5. 1 take away -1 is 2. So 1.5 divided by 2 gives us 3/4. That is a positive number, hence we're on the right track. So we know that the gradient of that line is 3/4. Now we find the equation of the line using y equals mx plus c, our formula in slope-intercept form. So to find the equation of the line of the normal, which is also the equation of the radius, we can substitute either points, either the 1, 2, or the -1, 1/2 for our x and y values, and both of them will satisfy our equation and give us the right answer. So in this case, I have chosen to use 1, 2 because it's easier. There are no fractions to deal with. So when I substitute, I'll have 2 is equal to 3/4 times 1 plus c. 3/4 times 1 is just 3/4. When I transpose, I'll subtract it from 2. 2 take away 3/4 will give me 1 1/4. Hence, if m is 3/4 and c is 1 1/4, the equation of my line is y is equals to 3/4 x plus 1 1/4. Now, on to the tangent line. So if the gradient of the normal is 3/4, then the gradient of the tangent line will be the negative reciprocal of that. It will be -4/3. Now, to find the equation of the tangent line, I have to use the point 1, 2. I cannot use the point -1, 1/2, because the point -1, 1/2, which is the center of the circle, does not lie on the circumference of the circle where the tangent passes through. So I have to use the point on the circumference of the circle, which is 1, 2. So this time, instead of finding my equation of the line in slope-intercept form, I'll use the standard form. Y minus y1 over x minus x1 is equal to m, and I substitute my values. So I'll have y minus 2 over x minus 1 is equal to -4/3. Next, in solving this, I cross multiply both sides of the equation. So I'll have 3 times y minus 2 is equal to negative 4 times x minus 1. Please note, I could have carried the negative with the 3 over to the left-hand side. It was just my choice to keep it with the 4. It doesn't really matter. In the end, you'll get the same answer. Next, expanding brackets. I'll have 3y minus 6 is equal to negative 4x plus 4. Collecting and having all terms on one side equal to 0, I'll have 3y plus 4x minus 6 minus 4 is equal to 0. Simplifying where I have the x term, then the y term, then the constant equals 0, I will get 4x plus 3y minus 10 is equal to 0. And that is the equation of the tangent line. Please note, if you chose to find the equation of the tangent line in slope-intercept form, you would still get the same correct answer, just in a slightly different form. Next, let's look at 3 possible cases of how the tangent line may interact with the circle. Well, technically, if it only touches the circle at one point, then it is a tangent line. If it touches it at 2 points, then that's technically called a secant line. And if it doesn't touch the point at all, then it is neither of those. So, when the line crosses the circle at 2 points, then there are what we call distinct routes, 2 separate routes. If it crosses the circle at only 1 point, then you have what we call real and repeated routes. However, if the line and the circle do not intersect at all, then you have imaginary routes. So when you are solving the equation here using the quadratic formula, if you try to find the square root of a negative number in your working, then that means you have imaginary roots, and hence the line does not cross the circle at all. So let's look at an example. Let's say we're to find the point or points of intersection of the line 3x minus y minus 1 equals 0 and the circle with the equation x squared plus y squared plus 2x minus 4y plus 1 is equal to 0. How do we go about doing that? Well, when we look at this, we should see that it's just a pair of simultaneous equations. We can take our first equation and rearrange it to make y the subject. So we'll have y is equal to 3x minus 1. Why do we want to do that? Because we want to substitute that equation 1 into our equation 2. So in doing so, we'll have x squared plus 3x minus 1 quantity squared plus 2x, take away 4 times 3x minus 1 plus 1 equals 0. Expanding brackets, I'll have x squared plus 9x squared minus 6x plus 1 plus 2x minus 12x plus 4 plus 1 is equal to 0. Collecting like terms, I'll have 10x squared minus 16x plus 6 is equal to 0. So now here I have a quadratic equation. You can solve this any way you like, using the quadratic formula, using factorization, or using the method of completing squares. Whichever way you do it, you will get that x is equal to 1 or x is equal to 3/5. So next, we have to find the y coordinates. So you substitute those two values into either equation to find the y coordinates. You can substitute it into equation 2, which is the equation of the circle, but that would be much more work. It is much easier to simply substitute it into the equation of the straight line, which is equation 1. So y will be equal to 3 times 1, take away 1, or 3 times 3/5, take away 1. So when x is 1, y is 2, and when x is 3/5, y is 4/5. So the coordinates of the points of intersection are 1, 2, and 3/5, 4/5. So the line y equals 3x minus 1 is not a tangent line to the circle. Why? Because there are 2 distinct routes, 2 distinct places where the line and the circle intersect with each other. And with that, I'll say, have a good day. See you in class.